Today we're going to do 13.8 today and tomorrow. We'll focus on the local extrema, relative extrema, and saddle points today. Tomorrow we'll expand it to have boundary conditions where we need to check the boundary, and we'll have absolute values. We'll look for absolute extrema. And then I also wanted to address a question Lawrence had yesterday. We'll get that done today. I put it on Discord, but I think I need to say it for the class. So extrema the critical points, as a reminder, or as new information for those of you that have slacked and did not watch the videos, exist when f of x equals 0, or the partial with respect to x equals 0, and the partial with respect to y equals 0. And then once you have it, you can do the determinant of that, which is fxx, fyy, minus, and since f of xy and f of yx are the same, minus that squared. We check that afterwards.
First time I've actually seen this first now.
You also want us to find the values of those extremas at those points?
Sure.
Okay.
If it's a min or a max, the saddle point doesn't really matter.
Yes. Because that's a three-dimensional point, right? The saddle point.
Yeah.
Okay.
Well, I got completely distracted. What am I doing? Derivative with respect to x. Okay.
Wait, you have negative.
Ooh, what to do now? Decisions. I personally like just solving f of y for x. Whenever I see a single variable like that, I like to do that, and you plug that in to the other one.
Oh, okay, we get. Okay, but then you have to evaluate. You just said. 2 negative 1.
Oop. Okay. Did you guys all find a critical point at 2, negative 1?
Yes.
All right, good. Now what we got to do? We need to do this, which is, if I do it in the other notation, d2f dx squared, d2f dy squared, minus d2f dx dy squared.
3.
Oh, because it's the. Okay.
And if this is greater than 0, we got some good stuff going on. If this equals 0, and nothing. No magic.
And then it's a saddle point if it's less than 0, right?
Yeah.
Are there any other tests that you can, for testing a point when the test is inconclusive?
You mean to check to see what type of point it is?
Yeah, because if your test is inconclusive, you just have a point that you have no clue what to do with.
It's usually an inflection point. You could graph it. Frequently inflection point. So apparently our second order partial derivatives were not dependent on x or y. They're just constant values. This is 2 times 2 minus 1 squared is 3. So it falls in the greater than 0 category. So we will have a max or min. The way you check it, it doesn't matter which one you grab, because they both should have the same sign. Look at either fxx or fyy. If they're greater than 0, it means it's concave up, which means this would be a min. And if they're less than 0, it means it's concave down there and we would have a max. And so we can see that they're both positive. Greater than 0, we have a min. So 2, -1 is a min.
Oh, the second.
What was that, Lawrence?
Nothing.
So I assume then you wouldn't have a time when f of x would be positive or and f sub y would be negative.
Well, for that to happen, if you think about that, that would mean this part here is negative, and this part here is definitely negative. There's no way to end up with a positive value with that happening. When they switch signs like that, that's where you end up with the saddle point problem. So if the sign one, but if you have greater than 0, there's no way for this to be greater than 0 if these have different signs. Does that make sense?
Yeah.
For the value, did you get -3?
Oh,
If
that's
you
a
even
good
do-
question. I didn't actually do the value. Let's do the value. Yeah.
Not this coming
It-
Monday, next.
So this formula can be a little pain
Not this
to
Monday.
remember. I think I want to like go over this matrix real
I'll
quick.
review next week, pretty much. We
A little
saw
bit
two
better.
pretty-
So let's discuss that matrix a little bit better. And a way to memorize it. So when you're doing a 2x2 matrix, the determinant is that minus that. So fxx, fyy minus fxy times fyx. But we saw from Clause's theorem that fxy and fyx have the same value. So this is just really one of those squared. You'll notice an easy way of following along, if you do the first variable is x along the thing on the first row, and y is the first variable along the second row. And then you change that up, going down the columns. Then the first column is x, and the second column is y. Then you might be able to remember this fairly easily. Even better, they're alphabetical along the top and not alphabetical along the bottom. So that's one way of remembering it. Any questions about that? All right, we'll do some more in a second. Lawrence had a question yesterday. How did R prime of T naught turn into the X minus X naught, Y minus Y naught, Z minus Z naught? Remember, we were doing gradient of F dotted with R prime of T naught. This was for the plane. And that gave us fx times x minus x naught plus fy times y minus y naught plus fz times z minus z naught. And he said, where the fuck does this come from? X minus x naught, y minus y naught, z minus z naught. How does
Right.
r prime of t naught turn into that? That was the question. So we've got some curve. And at t equals 0, this is r of t0, also known as r0. And presume that t equals 0, we say that's x0, y0, z0. So this point right here is r of x0, y0, z0. Well, I don't need the vector part right there. And we need a vector for r prime of t naught. Well, if you remember, r prime, we even did this in the last test, r prime was the first derivative. So r prime of t naught's here. Well, how do I describe that as a vector? I know its start point starts here. I don't know its end point if I did it as a, I don't have the terminal point, I should say. And since I don't know the terminal point, I'm going to call it x, y, z. And so to write that as a vector, you do finish minus start. X minus x naught, y minus y naught, z minus z naught. And that's where that comes from. Does that make sense? Does that clear it up at all?
Yeah.
Like this is just showing it in one dimension. The two, it's just more complicated to show visually in multiple dimensions, but showing a side profile of it like this kind of makes it a little bit clearer. And we used this x minus x naught, y minus y naught, z minus z naught before when we did tangent planes back in the end of chapter 11. All right. So next problem for you guys. Find the extrema for that problem. A little reminder, I'll put up that this is for D, and there's a bunch of F's in there.
Is it possible to do this without a point?
What do you mean?
Oh, in the previous example, we had like oh wait, never mind. I'm dumb.
No, we didn't. We found the point.
Yeah, we found the point. Yeah.
Did you have a
So what
question?
happens when we do this here?
It's, that's your device.
So we see that this one's kind of straightforward, x equals 0. And this one we get e to the y has to equal 1. Hopefully you remember that occurs when y equals 0. The other option is taking the natural log of both sides. And we have y equals the natural log of 1, which we also know is 0. So we've got a point, 0, 0. I've got fx and fy there. So fxx, the second order derivative is 2. Fyy is negative e to the y, and at 0, this is negative 1. And we can see the mixed partials are 0. So d equals fxx fyy minus fxy squared. I've got 2 times negative 1 minus 0 is negative 2. When this value is negative, this is a saddle point. And that occurred at 0, 0. That's what we were just checking. You guys ready for another one?
Mr. Jones?
Yeah.
So I just had a question. So for the saddle point, do you want us to put it in a XYZ coordinate or just leave it at 0, 0? Like, would you rather prefer? 'Cause obviously, the z is going to be whatever the
This
value is.
Z is the value of the function. So
Right, yeah.
leave it at the 0, 0, because the original function was in terms of xy only. I'm just leaving it at 0, 0.
Okay, but if we did plug in, like, if we did say the saddle point was 0, 0 and then negative 1, which is what we would get if we plug that in, would that be incorrect?
That's fine.
Okay.
Yeah, later on, you gotta do it anyway.
So he was asking if we say z equals f of xy and we do f 0, 0 there, we get 0 plus 0 minus e to the 0, which is negative 1. Can I write this as 0, 0, negative 1? Yes, we can write it as that. That's valid.
Thank you.
Any other questions?
think we're good to move on.
Everyone ready?
Yeah, we're ready.
Nice like this. So we get in the museum. Right.
Anything we can do to this?
Yeah.
What?
So I had said that because we know E to any power is going to be a positive number, it's not going to be relevant to equating what it's going to be as 0, but we know that sine of a value can equal 0. So I put that in this case for the instance of the partial derivative of x, y could equal 0 plus k pi. And for the partial derivative in respect to y, x would equal pi over 2 plus k pi. Those are the points where, different points where you could say that those values would equal 0.
Okay, so since that's always positive, this only works when sine 0, so multiples of pi. And this is only 0 at, let's see how you put it. It's pi over 2 plus n pi.
Yeah.
Okay. Are they ever 0 at the same time?
Hold up. I'm sorry, hold up,
froze,
Mr. Jones.
Professor
Your share screen's just froze.
The whole.
Are you still there?
I think it's, unless it's just like a taxi right now.
Okay, I'll call him up.
You just try to leave the phone.
Lost the.
He's also thought.
He probably is. He's like, any questions?
He's like, does that make sense?
It's like, why isn't no one saying anything?
Yeah. Okay, so it was on your end. You're like, you literally just froze.
Okay, I don't know why I got booted. I'm back now. Let me reshare screen.
Oh, that's a backup.
All right. So I don't know where I got cut off, so I will start again. We need them to
20
equal
minutes
0 at
ago.
the same time. I assume you can all see my screen right now?
Yes.
Yeah.
Okay, so we need them to equal 0 at the same time. Over for f of x, when f of x equals 0, this is at multiples of pi. Oh, and negative multiples, and we could keep going like that. This one is at pi over 2, 3 pi over 2, 5 pi over 2. And we go the other way, negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. Just, is there ever any time where they're both equal to 0?
No.
No. There is no time where they both equal 0. Thus, no critical points. Which means no max or min, or no extrema in general. That's crazy.
That's a fun one.
Isn't that a fun one?
Yeah,
So
you'll
think
probably have to. Or why don't,
Lawrence is asking if you,
why don't we just like see that is not a real function at ln is 0? It's like, you know, you try to solve for x, you get like ln is 0, and this doesn't exist, so therefore there's no relative. Why do you have to go through all this?
Wait, what?
Wait, what do you?
Just because a function doesn't exist, where are you even getting ln? Like, where's that coming from? I'm not understanding where you're going with it, so where you're starting with it.
It's like I just tried to solve it like the standard way. You know, you get x on one side and y on the other side, and solve for one using. the
Oh,
other.
so you're like solve one of these?
Yeah, like you just solve that for e to the x equals 0, and try to get x by the, you know, log.
The problem with doing that is you can't, because sine y sometimes equals 0. So it doesn't matter what natural log of e to the x equals when sine y equals 0. So like doing this, sure, that doesn't work because we can't take the natural log of 0. So doing this operation itself doesn't make sense to do. Because remember, this is like a times b equals 0. I just froze up again. God damn it.
Yeah. Indeed.
You got that AT&T Wi-Fi, huh?
oh, I think he's really frozen now. Oh, there he
Oh,
goes.
it's gone. Goodbye, Mr. Jones.
Bye, Mr. Jones.
It was a fun class day.
Oh, you know, look at the corner of his screen. No internet.
I told you, got that AT&T.
He's on that McDonald's Wi-Fi right now.
Everybody had him on the Discord.
Add him on the Discord.
Get him on. Hey, see if you could.
Oh, Jericho's the host now.
Jericho.
Jericho, I
Jericho,
believe
teach
in
us,
you.
Jericho.
Lead the class.
Jericho, teach us your ways. You've been promoted to teacher.
It's God. It's so weird. Your service animal.
Hard to imagine your first animal.
Use your imagination.
For real, all my friends from Dolphin or MLS. Keeps flickering, let's hear about. Oh, no, I just really like right away. Oscar. It's no comment at all. So there's no crazy thing. Oh, you had a question, right? Let me see if I can do like answer. Oh, you did?
Yeah.
I think was I. Then our was high class. So okay. So in terms of that, right? All right. Okay. You guys are probably excused. You printed this where they started it up. If you have any questions, he's trying to get himself back on. No, why cannot be the same value. Then 2 days.
Wait, but how much? That's like 2 hours. I will see you guys tomorrow. I don't know why my internet was flickering. My router doesn't have any problems. It's just my computer decided to give me the big FU.
We did notice in the middle, in the corner of your PC while you were still frozen that you had no internet.
Right. So I will see you guys tomorrow, and we will do include boundaries and check absolute conditions tomorrow.
Pretty adept. I mean,
There's not have time to sit there for 2 hours.
Yeah. Hey, Mr. Jones.
Yeah.
Real quick before you go, can I ask you a question real quick?
Of course. That's why I hopped back in.
Okay, sweet. So when we were doing, oh god, let me find it. Let me see here. No, I'm trying to find it. Okay, yeah. So we had done a problem where you had said find a unit vector in a direction which f increases the most, f decreases the most, and f has a level curve or is contour.
Yeah.
So I had put that the so each of those values have to be in the in the form of the unit vector that we find, right? Because I had put that nobla f was equal to 3 was equal to 3 comma negative 1/4, but that's not in terms of the unit vector though. So would that be not right then?
It's you've got the direction, but not the right magnitude.
But not the right magnitude.
So where's what the hell happened to my visualizer? God damn it. Bring that back up.
All the connection problems today, huh?
Yeah, this thing just shut down on its own. Let's see. I gotta redo the resolution and I gotta spin the camera. Wow, and then it's all blurry and shit. Okay. So we had 3 negative 1/4. That's the right direction, but to find to make it a unit vector, the magnitude has to equal 1. So we divide by the magnitude. That's how we remember when we were doing tangent, normal, and binormal.
Yeah.
We did the same thing with tangent. You take the tangent vector and divide by the magnitude of the tangent vector, or r prime over r prime. And that will give you a unit vector. Other than that,
Yeah, because we had found out what the unit vector would be after we did the magnitude. But then for some reason I went back and then for the answers I just put what the direction was, but I didn't actually put it over the magnitude. So, but when I look back over it, I'm like, wait, why did I do that? Because that wouldn't be correct, because if we're trying to find it in terms of the unit vector, then I have to put everything,
Right.
I have to put vector notation, in terms of the magnitude as well.
right. So when we divide by that, we could multiply by the reciprocal. I believe that's what you have in your notes right there.
Yeah.
Yeah.
Sweet.
All right. You all
Appreciate
good?
it, Mr. Jones. Yeah.
All right, then I can go ahead and sign off. I'll
All
see you
right, take
tomorrow.
care.
The class ended already. I got disconnected.
Yeah, we're ending it early, because I was getting disconnected too. Sebastian's was just asking questions. We'll continue on this subject tomorrow.
All right. I'll just. I had some stomach issues. That's why I admit wasn't able to make it, at least not physically, because
I'm sorry to hear that. I hope you feel
Yeah.
better.
I've